In this video, we're going to discuss CRA models for whole number division strategies that are based on place value and properties. So this won't be a fully exhaustive list, but these are just some of the strategies that would fit into this category. So this first one is called, one of the names you'll hear called is think multiplication. So when we have a division problem, if we're using this strategy, what we're doing is we're using multiplication to solve a division problem. So if we have 21 divided by 3, we can think of this as either 3 times what equals 21, so 3 groups of what size equals 21, or how many groups of 3 would equal 21. Okay, so it's kind of related to that inverse relationship with these operations and those fact families. So we can, if we don't know what 21 divided by 3 is, but we do know some of our multiplication facts for 3's, you might be able to figure this out as well. Start with a concrete model. I'm actually going to do this variation right here. So we're we're trying to figure out how many groups with the size of 3 would give us a total of 21. Okay. So I just have this one. I just have some connecting cubes. I'm going to treat them like a set model, but I have them grouped in these groups with the size of 3. Okay, so if I have, that's one group with the size of 3. So I only have a total of 3, so I'm not to 21 yet, so let's keep going. So another group of 3. Okay, so now I'm at a total of 6 with 2 groups. Another group of 3, I'm at a total of 9. Another is going to be a total of 12, 15, 18, and 21. Okay, so now I can look and see, I have 1, 2, 3, 4, 5, 6, 7. So 7 groups of 3 gives me a total of 21. So I know then that total there, or this multiplier here, is 7. And then if I go back to my division expression, that 21 divided by 3, then I know that the quotient to the answer is going to be 7. So 21 divided by 3 is 7. So that's a concrete model. Right, for a drawing, we don't necessarily have to start with any, but we can, again, if we want to look at, actually, I'll show the other variation just so we can see this 3 times question mark equals 21. So this would be 3 groups of what size equals 21. So this would be a representational model. So again, just some drawing. So these are my 3 groups over here. So I put 1 circle into each group. I have a total of 3. So I need a total of 21. Okay. Put 3 more in each group. So now I have a total of 6. Total of 9. Total of 12. Total of 15. Total of 16, or 18. And then now a total of 21. So then I'm looking to see, okay, 3 equal groups, what is the size of each? Each has 7 in there. And then the abstract model is going to be thinking of this as that multiplication expression. So that'll be the abstract for this case. Okay, so I think multiplication is one strategy here. Another is going to be repeated subtraction. Okay. So we had kind of talked about multiplication as repeated addition. So we're thinking of it. This is kind of the same type of idea. We're thinking of division as repeated subtraction. So again, 21 divided by 3. Again, it'll be a little bit similar to the strategy we looked at last time. But we're not solving this by thinking about this from a perspective of multiplication. Some of the steps might look a little similar. So 21 divided by 3, again, we can think of this divisor as either the size of the group or the number of groups. If we're doing repeated subtraction, we're generally thinking of that 3 as the size of each group, because we're just going to repeatedly subtract groups with the size of 3. Right, so it's one group, and we're just subtracting these one at a time from that dividend, or that starting amount. So third group. Four groups. 5 groups. So with each of these, I'm just subtracting 3 from that total every time. So I'm just repeatedly subtracting 3. So So then again, I can see there's 7 total groups. So 21 divided by 3 is going to be 7. Okay. So that's the concrete model. For a representational model, for a representational model for repeated subtraction, if we want, we could kind of cross these out and show them drawn below. Again, we can kind of just signify, circling a group of 3 and just kind of envisioning, okay, we're taking that away from the total, so this is what we have remaining. So there's 18 left. Take another group of 3 and just go through. Again, just taking away 3 at a time. So we can see that we've taken away 7 total times there to see that we have 7 groups. Okay. And then for the abstract, if we wanted to, we could write out each individual step here. 21 minus 3 equals 18. And then, oops, 18 minus 3 equals 15. 15 minus 3 equals 12, and so on. And then we're just looking to see how many times did we subtract 3, how many groups of 3 did we take away. So once we would go through all these steps, right, we would have 7 different occurrences where we subtracted 3 from that total amount. So let's repeat subtraction. This next one will be called decomposing the dividend. Okay, so here we have 21 cubes, right? So our dividend is that first number in a division expression. So we're going to decompose this number, this 21. So in the concrete model, all that looks like, so if we have all 21 cubes, maybe we don't know. We'll say our divisor 3 is the number of groups here. Okay. So maybe we don't know how many would be in each of those 3 groups from 21. Okay. So maybe it's easier for us to just first think of just these 15. Maybe it's a little easier for us if we can. Maybe we know what 15 divided by 3 is. So we'll decompose this 21, or kind of separate them into two categories. So the 21 has been decomposed into 15 plus 6. So first we're just going to take the 15 and divide that into 3 equal groups. So maybe we know that 15 divided by 3 is 5. So just in one move we can place 5. Oh, looks like I had 14 and 7, so 20. We wanted 15 and 6. Okay, so we'll just take 5 into each. Okay, so we did 15 divided by 5, or 15 divided by 3. Let's see that we have 5 into each of those, okay? But then we still have this original 6 up here remaining. So now we have to do 6 divided by 3, so we want the 6 divided into those 3 equal groups. Place those, then we can see that we have 7. Okay. So again, with this strategy, it's important that we can only decompose that dividend. Okay, we can't decompose this because that changes we won't have equal groups by the end of this. So for example, if we were to do 21 and then we tried to decompose this 3 into 2 plus 1 or something, right, we would end up having 2 groups that have a size of 10.5 and 1 group that has 0. So we don't have equal groups, so we're not able to do that in that multiplicative structure related to division. So you can only decompose that dividend, but we can decompose that however we would like. Okay. So that's a concrete model for that strategy. And then representational is going to look similar. Okay, so we have 21 counters. Again, maybe we can't quite easily see how many to put into each of the three groups if we have all 21. So again, all we're kind of doing is just, we're thinking of this in two separate pieces. So here I have 15, and then again, maybe I know I can put 5 into each group if I have 15, trying to be divided into 3. Okay. And then I have those 6 remaining, so 6 divided by 2, or 6 divided by 3 is going to be 2. So that's a representational model for how to solve using the decompose the dividend strategy. And then the abstract model that goes along with this, we might not necessarily always write it out this way. Right, we decompose this 21 into 15 plus 6. Okay. And then since division is the inverse operation of multiplication, all the multiplicative properties still apply. So then we're using that distributive property. We're distributing this divided by 3 throughout this entire quantity. So this will become 15 divided by 3 plus 6 divided by 3. Okay. Another way you can kind of think of that, might make a little bit more sense. We can also think of this divided by 3 if students are working on these and have gotten to multiplying by fractions. Right, we can think of that as multiplying by 1/3 instead of dividing by 3. Then it might be more, oh sorry, this should be a add right here. This might make it more clear that we can use that distributive property. So 15 times 1/3 and then 6 times 1/3 as well. Okay. But then again, with the 15 divided by 3, that first move, we put 5 into each group. And then we did 6 divided by 3, so we put 2 into each of those groups. So each group had a total of 7. Right, so that's the decompose the dividend strategy. And then the last one is going to be area model strategy. Okay. Okay, so for this, if we're thinking of from an area model perspective, right, our divisor here, or our dividend, sorry, 21, that is going to be the area of the rectangle. Okay, and then divided by 3, so our divisor of 3, again, this is telling us that either we have 3 rows, or rows that have a size of 3, or 3 columns, or columns that have a size of 3. We can kind of interpret it any way that we would want for the area model. But so this same, we have an area of 21, so we have 21 square units divided by 3. I'll just say this is, we're going to divide this into 3 rows, and we want to see how many cubes are in each row. What's the size of each row? Okay. So again, with the area model, maybe I recognize, I'm going to kind of, this will be a little bit similar to decompose the dividend strategy as far as what numbers I'm looking for in the steps. But maybe I know I can make 3 rows of 5, and that will be an area of 15. Okay, so that's kind of my first step here. Alright, so I'm taking these cubes and just organizing them into an area model. Okay, so I have 3 rows, each have a size of 5. I still have some left over here. So you can see I have 6, so then I look and see, okay, I can put 2 more into each of those rows. So I can see if I have a rectangle with a total area of 21, so I have 21 square units, and I have 3 rows, each row has to have a size of 7. Okay, if we wanted to think of it as 3 columns, right, we could have just done the exact same thing. It would end up just like this, or if we would have said rows with a size of 3, it would look like this. So that's our concrete model for that area model strategy. Okay. And then for drawing of an area model, so I'm going to draw kind of one over here first. So again, what we're kind of trying to do with the strategy that I'll show right after here is we want there to be a rectangle with a height of, again, we'll go a height of 3, so 3 rows, then has an area of 21. We're trying to figure out what's the width of that area, or of that rectangle. Okay. So kind of how we would start out in this strategy. Let's say I have my height of 3. And I'm kind of doing the reverse of the box method. Okay. So maybe I know I can make an area of 15 if I have a small portion with the width of 5. Okay, so this little area that is 3 by 5 has an area of 15. Okay, I need this total box to be equal to 21. So then, again, we can put a small little area of 2, and that would give us 6. Okay, so now this entire rectangle has an area, right? The 15 plus 6 equals 21. Okay. So that's a representational model, the area model. And then for the abstract, this could look a couple different ways, kind of depending, because I was kind of talking about multiplication and division at the same time. So again, if you were thinking it from more of a division perspective, right, this might look more similar to that decompose the dividend strategy, right, where we had 15 and 6 divided by 3. Really kind of how I was thinking of this is 3 rows of what equals 21. So you can see how we're kind of blending some different strategies here. Right, so I had 3 times 5 was 15, and then 3 times 2 was 6, and these two add to 21, so I had the 5 plus 2. So that's our abstract model to kind of go along with the area model. So again, these aren't a fully exhaustive list of strategies that would fit into this category. We're just some that we're kind of flexibly working with the numbers using some of the different properties and place value concepts.